okay, by now you should know that the Earth goes around the sun and the moon goes around the Earth, right? And as they go around in orbit, um, there you got the actually a course of a year. We're going to be getting into that in just a little while. But here's the thing. I want people to try to get a little bit of a, oh, let's just say, a vision of the proper scale of things in the solar system, right? That would include the sun, earth, and the moon in this case, and then you got the other planets, but let's just leave it with sun, earth, moon. Okay, you made a model, right? And in your model, you should have had the sun being bigger than the earth, just like this one, and then the earth being bigger than the moon, just like that one. And the earth goes around the sun, right? Yeah. And the moon goes around the earth. Okay. So here's a model, that we have in the classroom. And, this is really nice. It tells the truth, right? It tells the truth that the earth goes around the sun and then the moon goes around the earth. Come on. There we go. Anyway, but does it tell the whole truth? What I mean is this the correct distance relative to each other? And is this the correct size relative to each other? So you already saw a video about it. You might have an idea that it's not. The truth is, the moon at this scale is about the right size, and you can tell it's about the right size if you one little shortcut. If you look at the United States, the moon doesn't quite go all the way across the United States. That's the correct size. So this is how big the moon is relative to the Earth. But the distance is more like this. Okay, it's further away than what you would have on a model like this. And you might see why, because if you had a model with a wire this long, it would take up a lot of space, right? Now, suppose, I don't know, let's say what we're going to do is we're going to actually do a scale model that is accurate size relative to distance and to size to each other. Now, this scale won't really work all that well for what we're going to do. And I want you guys to participate in this. We're going to take a look at the real sizes of the objects, and we're going to do a model at 1,000,000,000 to 1 scale. 1/1000,000th the size. Now, the nice thing about metric, as opposed to using miles and inches, using kilometers and centimeters and millimeters, it's really easy. All you got to do is move that decimal point. It's very easy to convert to divide by 1,000,000,000. You just move the decimal place over. Okay, so we're going to do this together. I'm going to kind of walk you through it. And the question is, if let's suppose I contacted the company that made this, which is here we go, Hubbard Scientific of Chippewa Falls, Wisconsin. And I said, I want an accurate scale model. And they go, okay, 1,000,000,000 to 1. Gotcha. And the question is, how big would the Earth be? How big would the moon be? How far apart? How big would the sun be? And how long would this arm have to be? Okay, so let's go ahead and get some of those accurate sizes. Okay.